Hi, everybody. In this video, I'm going to go through lesson 4.10 on quadrilaterals and their properties. And this is primarily going to focus on trapezoids and kites. And we're going to start out by talking about the properties of a trapezoid. So a trapezoid is a quadrilateral with exactly one pair. I'm going to do one with the underline, one pair of parallel sides. So drawing a diagram here, I have two sides, and these two sides that are parallel are known as the bases. So I have base one and base two, and then the two not parallel sides are known as the legs. So there's one of our legs, and there's another one of our legs. I'm gonna label it as base and base. We'll talk about base one versus base two later on. So the bases are parallel. So let's draw those parallel sides in here. This is A, B, C, D. So BC is parallel to AD. These are these two parallel bases. In a trapezoid, we can have a special type of trapezoid known as an isosceles trapezoid. So an isosceles trapezoid is a trapezoid with congruent legs. So trapezoid with congruent legs. So this first example I created here is not an isosceles trapezoid. Those two legs are not congruent. So this example here is not isosceles. So an example that would be isosceles. This is kind of what your traditional trapezoid looks like. Let's see how I did. Move this over just a little bit. Whoa. Okay, fine, it's fine, it's fine. This is going to be an isosceles trapezoid here, A, B, C, D. The two bases are still parallel, but now the legs, A, B, and C, D, are congruent. So this is an isosceles trapezoid because those two legs, A, B, and C, D, are congruent. Now, isosceles trapezoids are pretty cool because in an isosceles trapezoid, the base angles are congruent. So in this diagram, that would be the bottom two angles, angle A and angle D. Those two angles are congruent. And the top two angles on the other base, oops, B and C are congruent. So angle B is congruent to angle C. So notice that A and D are the two angles along the bottom base of the trapezoid, and then B and C are the two angles on the top, right? On the top base of this trapezoid. So those base angles are congruent, and additionally, in a trapezoid, we also can state, oops, that our diagonals are congruent. So only in an isosceles trapezoid, we can say that our diagonals AC and BD are congruent. And then of course, I never actually wrote out that AB here is congruent to CD in an isosceles trapezoid. Okay. One other thing we need to talk about with trapezoids, and this is true for all trapezoids, is they have a mid-segment. So let's talk about the trapezoid mid-segment. So the trapezoid mid-segment, as it may sound, it's the line connecting the midpoints of both legs. And this is, again, this applies to all trapezoids. And our general mid-segment formula, if I want to find the mid-segment, if I want to find the length, I would take the length of my base 1 and add on the length of my second base, base 2, and I would divide it by 2. So your length of your mid-segment is essentially half of the sum of your two bases. So if I have a trapezoid, and I bet I could just be using this tool. I always forget about that sometimes. So if I have this trapezoid here, A, B, C, D, this mid segment connecting the midpoints E and F, right? So this divides, E divides A, B into two congruent halves, and F divides CD into two congruent halves. And then if this is an isosceles triangle, then we know that those halves are all the same, but I don't necessarily know that in this triangle, or in this trapezoid, excuse me. So then the mid segment would be this line segment EF. And the mid segment, please note, your mid segment is parallel to both bases. So that's your mid segment. And notice that this is the line connecting the midpoints. So just in case you need a refresher from Algebra 1, I know it's been a minute since we've talked about midpoints. I don't like it. I don't like the way it looks. We're just going to write it. Midpoint between any 2 points is always going to be itself a point, right? An x comma y. And it is the average of your x values, x1 plus x2 divided by 2. And that's the x coordinate. And then your y coordinate is the average of your two y values. So if you're provided just the coordinates of your trapezoid, you can still find the coordinates of the mid-segment. You just have to find your midpoints first. So please remember this midpoint formula that requires you to take your average of your x values and the average of your y values separately. All right, let's talk about kites. So I like kites. Kites are fun. A kite is a quadrilateral, has 4 sides, and it's a quadrilateral with 2 pairs of congruent adjacent sides. Congruent adjacent sides. So a kite, hopefully you are familiar with what a kite looks like. And let's see. Oh man. Let's see if it'll autocorrect. Okay, so let me do it a little bit more how I would draw it by hand. So you have two congruent adjacent sides. So two pairs of congruent adjacent sides. So here are two congruent adjacent sides, and then you have another set of congruent adjacent sides. I don't think this works. So if this is kite, this would be kite A, B, C, D. And in this kite, some properties here, we have exactly one pair of opposite angles. So exactly one pair of opposite angles are congruent. And the way you can determine what angles that is, it is the angles where your non-congruent sides meet up. So I have angle A and angle C that are congruent. Where the non-congruent sides meet. So I can actually say that angle A is congruent to angle C. Be a little bit more precise here. So one pair of opposite angles are congruent. And then we also can say in a kite that these opposite angles, these two angles are bisected by their diagonal. So there is a diagonal, right? There are two diagonals in this shape. We have diagonal AC and BD. So here we now know that A and C have been bisected by segment AC. And then I'm going to label this point here just in case we need it in the middle. This will be point E. Now, another kind of neat set of information, this is for our example, so I'm going to kind of move that down. Another kind of neat thing about kites is that their diagonals are perpendicular to each other. So the two segments themselves, AC and BD, are perpendicular to each other, which means these angles, right, AEB, BEC, CED, those are all 90 degrees, right? They're right angles. Also, one diagonal is the perpendicular bisector of the other. So that means one diagonal, we already know they're perpendicular, right? So one diagonal is bisecting the other, but the other one, right, the other diagonal isn't bisecting the first one. And hopefully looking at my drawing, you can kind of see here that the diagonal BD, BE is certainly shorter then ED. Those are two different lengths. It's always going to be the diagonal going across those two congruent or opposite angles. So the diagonal that cuts across those two congruent angles that we already established, where those non-congruent sides meet, that's going to be the one that gets bisected. So I can tell here then that AE is congruent to EC, and that AC is equal to half of AE or half of EC, right? They're the same thing. And you could add those two together to get AC. All right, I am going to do the examples in a separate video, so please go ahead and head to the next video now.